Hello, my name is Dylan Webb. This is my Lab 9 Part 2. We have constructed a ring counter that is a Mod 4 counter, has 4 states. We are implementing the idea of buses again, with all of our clock inputs being routed to the same clock pulse here. So we have that going into pin 3, and then all the clock inputs from the other gates are also going to pin 3 using that bus system. And then for pin 4 for our pre, we're connecting the pre input of our first flip-flop as well as the clear inputs of the rest of our flip-flops B, C, and D to switch 1. So to do that, we're using pin 4 as a bus where the pre is going, and then all the clears are going after that pre at the pin 4 of our first D flip-flop on our first chip. The clear input of this flip-flop, which is going to be pin 1, is going to VCC right here. And then the pre-inputs of the remaining flip-flops, B, C, and D, are also all going to VCC, as you can see. And each chip is grounded and powered as it should be. In this case, different from before, instead of the inverse output being routed back to the first D input of the first flip-flop, is instead the normal Q2 output. So it's going to be pin 9. So instead of pin 8, it's going to be that pin 9 with the jumper wire going back to pin 2 of our initial flip-flop in order to cycle the counting. So yep, this is my Lab 9 Part 2. It's a basic ring counter. Thank you very much. Oh, also each output is of course going to an LED. And thanks.